Hey, good day folks, and welcome to another one of my videos. This is the second video in my series about terminal games, and in the series we're building a game of Snake. So in the previous video I looked at how we can pull the user input, and today I want to look at terminal graphics. So the goal for today is for us to draw a basic board and have a single cell that we can move around the board using user input. So for terminal graphics, I will use the ANSI escape codes. Now these escape codes were introduced to have a standard protocol for controlling the output on video terminal devices, such as we see illustrated in this picture. Now today we don't really use these video terminal devices anymore, but we've got terminal emulators on our Linux and Unix systems. Now the ANSI escape codes are still widely supported among those modern terminal emulators. I am specifically interested in a subset of escape codes known as the control sequence introducer commands. So these commands typically start with an escape character followed by an open bracket and then some sequence of characters that represent the command and the arguments for that command. So just a reminder, in the previous video we implemented a mechanism to pull user input one character at a time. So every time the user enters a character, we will print it out on the screen, and when the user enters Q, the application will terminate. So let's start by converting those characters into actions for the game. Okay, so the game actions will be represented by an enum. Now there is a few different types of actions, so we could say there was a non-action, so we pull and there was no user input. We can say that the user entered the quit key, or we can say that the user entered some direction, like up, down, left, or right. Cool, then we're going to go back to where we pull the user input. Now instead of these if statements that we have here, let's use some pattern matching to convert that into an action. So Q's going to be quit. Then I'm going to start with what should be very intuitive for everybody who spends a long time in the terminal. Now again here, you need to spend some time in the terminal to understand why those would be the most intuitive keys for up, down, left and right. Otherwise, if we don't recognize the character, we're just going to say that that's a non-action. Cool. Then what we would want to do is we would want to use these actions to update the game state. So in this case, I'm just quickly going to implement the quit action. Okay, and we'll start by implementing the other actions soon. Okay, let's just give that a quick run. Okay, so nothing happens until we enter the quit key. Okay, let's add Stdout to our main application. So this is going to be very similar to what we've done for standard in. So Stdout would be equal to std.io file stdout, and then we will need to have a buffer. Now what I would want here is I want a buffer that's large enough for us to fill it with all the control sequences and then flush it in a single step. What I want to do is I want to avoid having multiple smaller write events to the terminal, which may introduce some flickering. Okay, so let's start by giving this a very big buffer. I reckon 64K should be enough. Okay, now we can use the buffer to create our writer. So again, we need to pass in the IO argument, and then our Stdout buffer as a slice. Okay, now what I want is I want to have an alias to the interface for this writer. So let's just call it const writer, and that should be a pointer to our writer's interface. Just to make it easy so that we don't have to type all of that out every time we want to do something with the writer. Now there's a few places where we'll definitely need to use the writer. So I'm going to have some setup instructions over here, and then once that's done, then I would want the buffer to be flushed to the terminal. Then at the end of our render instructions, I would want to flush that through to Stdout so it can update the terminal. And then in our cleanup instructions at the end, we need to flush the buffer to Stdout. Okay, let's give that a quick go. Okay, righto. So let's just queue. That still quits. So let's start with our first command sequence. So all of these command sequences will start with the same prefix. So let's create that prefix. So that would be, so 1b would be the code for the escape character, and then we need the open square bracket. So all our commands will use that same sequence. Now to start with, let's just clear the screen when we run the application. So we start with the prefix, then we concatenate the characters that would clear the screen. So that's going to be 2 and then uppercase J. So let's go to where we set up the Stdout. Okay, and what we'll do is we'll just write out the clear screen command. Okay, let's just give that a go. Now as we see, it cleared the screen. The cursor is now still blinking at the line 3 position. Okay, so next we probably want to move that cursor. It's pretty annoying to see it blinking there on line 3. So let's introduce the command sequence to move the cursor. So again, CSI, and then I'm going to concatenate the sequence for moving the cursor. So we supplied 2 digits, followed by an uppercase H. So that's first the row, then the column. Okay, so let's go where we clear the screen. So after we clear the screen, let's this time print, because I want to supply a formatted string with some parameters. and row and columns start count at 1. So we'll just need to remember that with the arithmetic later. Okay, let's give that a go. Okay, so this time the cursor is in the top left corner as we expected. Okay, so let's combine the cursor location with the user input. So let's have a location struct, and the location struct will have a row. Now I'm just going to use a U8 because there's just a limited dimension in which the row and columns can move on the terminal screen, and then the column is also going to be a U8. What I also want is I want to have some constraints on the board. So on the lower bound we know that the minimum row and column numbers would be 1, and on the upper bound I want there to be let's say no more than 20 rows, and let's make it 40 columns. Okay, so those are the constraints where we'll have the board later as well. Okay, now after we set up all the resources and before we start the game loop, I want our game state variables over here. So let's have our location variable, and we start row equals 1. Yeah, we start in the top left hand corner. Column equals 1. Okay, and now we can implement some more actions in updating the game state. So let's quickly go through this. So up. So if the locations row is greater than 1, then we can say location row decrease 1. I need to put the semicolon there. Otherwise, for down, we need to say if the rows is less than the rows constraint, then we're going to increment by 1. And that's our spell down. Next we're going to look at left. So again here, if the columns would be greater than 1, then we can decrease the column by 1. Otherwise, for going to the right, we want to check that the columns is less than the constraint. And if that's the case, we can increase the columns by 1. Otherwise, the only action remaining should be the non-action. And all this is going to do is just nothing. There's nothing to update when the user didn't supply any valid input. Okay, so what we can do before we flush on the end of the render, we can just print out the cursor location. And let's clean up that first move. Okay, so let's give that a go. So we can move down until we get to the bottom at row 20. We can move to the right until we get to the column boundary at column 40. And we can move all the way back up. Okay, now if we quit here, that looks a little bit suspect. So let's just introduce some additional cleanup instructions at the end. Okay, so before we flush, what I want us to do at this point is let's just write a new line at the end, and let's move the cursor to our bottom right position. let's see how that goes. Okay, so now regardless of where we have the cursor, when we quit, the prompt would return to the bottom of where we've drawn the board, so we can still see the state of the board before we go back into the code and debug. Okay, so at the moment we've got constraints for what would be the board area where the user may move the cursor, but the user can't see that area because it has the same color as the terminal background color. So what I want to do next is I want to fill in the color for the board area. Now, depending on what terminal emulator you're using, the command sequence will be different. So say for example on Apple, the terminal app has an 8-bit color or a 256 color scheme. So one would need to use this escape sequence over here to set the foreground or the background color, and you'd be restricted to the color codes in this table. Now I'm using Ghosty, which is a true color terminal, so it's got 24-bit color support. So this is the commands that I'll be using, where I can supply the red, green and blue values individually, each in the range from 0 to 255. Okay, so let's go and add the command sequence to set the color. Now what I'll do here is I'll modify the background color, and then I'll just print a space to generate a colored rectangle. Okay, because I might later want to combine different color schemes, if I check color support, I'm just going to use the -RGB suffix to remind myself what command I'm using. Okay, so the sequence here would be 48 for the background color, and then 2 to indicate that I'm setting the RGB values. Then we can have our R value, our green value, G value, and our B value, which is our blue value, ending with an M. Okay, let's introduce some colors. So for colors, I'll just use a struct, which will have a red, which is a U8. Okay, let's default these to 0 values. Okay, so RGB, and I'm going to introduce some constants as well. So let's say our board color equals to and I want a blue board. Okay, so let's go to where we flush the buffer for the first time. So we want to clear the screen, and then I want to print out I want to paint out the board area. So now, very important here, I need to remember the offset by 1 because I want to use the row value. Okay, and what we'll do is we'll just print out the command to move the cursor. So we supply the row and it will be in column 1. Now I'm just going to print the entire line full of empty space. Okay, and what I need to remember is I need to set the color. we'll set that to our board color. Okay, now I will need to do some cleanup afterwards, and that is I would need to reset the color. So let's go back up here. Okay, so that's going to be the prefix, and we'll use 0M to reset the color. And yeah, okay, so before we leave, what we would need to do so hopefully that will get all the colors back, so that the terminal doesn't look silly afterwards. Anyway, let's give that a go. Okay, there you can see the board area, and the cursor matches it. And if we quit, the prompt is on the line immediately after the board. Now, at the moment, we are still using the cursor from the terminal, but that cursor is going to get in the way when we start drawing our own graphics. So let's disable the cursor, and then we'll paint in our own cursor location. So what we'll do here is const cursor off. And the sequence for that would be okay, and while we're here we can introduce the cursor on as well, because we'll want to turn on the cursor when we're done. Okay, let's just put this in. Okay, so yeah, we can turn it off before we clear the screen. And then we can turn it back on when we're done. Cool. Okay, so that should turn the cursor on and off. Now we would want to paint in our own cursor location. So let's go back to our colors, and what I'll introduce here is just a cursor color. And we'll make that white. Righto. So we're going to go back to where we render the graphics, and then what we'll do is we'll just paint in our cursor after we set the color. Okay, and yeah, actually that can just be a simple right. Okay, let's give that a go. Okay, now we've got the line filling in there. Okay, so let's quickly fix that line. So we are going to just print out the cursor 2 times. So this is going to be set to the board, and we need to keep track of what the cursor's alt location was. So let's say there was an alt cursor location. Okay, let's try that. Okay, there we go. So instead of using the terminal's cursor, we've got our own cell or location that we paint as if it was the cursor. Okay, so we accomplished the goal of this video. So we can paint a board on the terminal, and we can let the user use keyboard input to move a location on that board. So for the next video, I think we should look at animating the location so it will move around at a certain speed, and we can look at building up the body of the snake and painting the snake. Anyway, this is looking like quite a long video already, so thank you very much for watching. If you like the video, click on the like button. If you want to see more, subscribe, and I will see you in one of my next videos. See ya.